Okay, so as I said, my name is Sundip Shah. I'm based in the Advanced Technology and Research Group at Arup, and I'm in the London office. I'm not a developer of Oasys software, but I am a user. I've been using it for 11 years. My background is in impact analysis using LS-DYNA. So today we'll be talking about post-processing, the Oasys Post update. Right, so before we start, I wanted to just give you a quick agenda. I've got about 90 slides to get through, so quite a lot of material. I hope to do that in about 45 minutes, so it'll be quite a quick pace. And at the end, if there are any questions, I can go through those. So we'll start with D3 plot version 14, the updates to that. Menu system changes, window sync tabs, dragging graphics window, contour ramp color changes. There's a new blanking menu, a new method of blanking per window. We have an additional feature which is plotting multiple on-plan integration points, right menu changes, volume 3 enhancements, plotting streamlines, support for new data components, and support for new interface files. Those are LS-DYNA input output files. And then just a quick update on reducing your PTF file size. Then we'll move on to THIS version 14. Support for new data files, new output files from LS-DYNA. There are some new JavaScript functions, and then a little update on Visual Studio IntelliSense. And finally, we'll end with Reporter version 14, some updates and improvements to the templates there. And at the end, I will also just go through 2 demonstrations. I think some of you might have seen those before, but if you'd like to stay for those, they're about 3 or 4 minutes each. Okay, so we'll start with D3 plot version 14. There are some menu system changes. Menus now contain options for selecting items. Now you will need a ZTF file from this, and that's created by Primer. So instead of the old style, we can click on object type to see a list of the available items for this type of menu. So this is a change to make it more consistent. So we can filter by list, and the list can be sorted by clicking on the header column. And items can also be selected by picking on or keying in the screen. So this should hopefully make it a little bit easier to select items in D3 plot. So again, we have Primer style object menus, and this is another example. So there's a change from version 13 where we selected things with the menu on the left-hand side. So things were, you had to click on a tab. But instead of that, we've changed it to the version 14 style, where it's much more consistent with the way that you do things in Primer. So this example is the new blank menu. Okay, the next thing is we also have a new right entity menu, and again we're being consistent. So instead of having a whole unsorted list there, we've got a standard list of items that we can select. Okay, the next change is to window tabs. If you're working in D3 plot with multiple graphics windows, then there are a lot of menus that display these window tabs, and that's to make the windows consistent. So previously in version 13, all of these tabs were independent. So setting tabs in one particular menu didn't change those in another menu. So for example, if you wanted your graphics window 1 to be consistent with graphics window 2, you would have to go into each of these tabs individually and then click on make consistent, which is the symbol there. Instead of this, in version 14, all of the sets of tabs are synchronized. So you only have to click on one of these and all of the options from all of the submenus will be synchronized. The only exception is the animate, because we found that most users wanted these options to apply to all of the windows all of the time. Okay, so there is no make consistent tab in the animate, but for everything else there is a... Okay. The next change is in version 13 we added the capability to drag menus, graphics windows out of the main application. So, sorry, in version 13 that was just for menus, and in version 14 we can also drag the graphics window out onto the desktop. Okay, so you can have one session of D3plot open and you can drag these individual menus and the graphics window elsewhere on your desktop, or indeed onto a different monitor. Okay. So any graphics windows that are not included in the main D3 plot, if you've dragged them out, they won't be included when you go to the image menu to capture a page. Graphics windows, so, and that's just repeating what I've said there. So that's just showing you what you would end up with. So if I go to the previous slide, the main graphics window is on the desktop, and these are the 4 windows in D3plot. So that is the image that you will get. Okay, the next major change is contour ramp colors. So by default, D3plot uses a rainbow contour ramp, and we've had this for many years actually. But this particular ramp is not colorblind friendly and is not particularly useful if you print in grayscale. So I don't know anyone who prints in grayscale anymore, but these enhancements will allow you to do so, and hopefully you will be able to actually distinguish the contours properly if you print in grayscale. So I'm told these names here, Viridis, Plasma, Inferno and Magma, those are standard names for the contour ramps, and you can select that under the data menu under the options for contour ramp, so you can change that. So this is an example of a particular plot, particular stress plot. This is it's the resultant displacement shown in the various different contour ramps, and in grayscale we can see that it's actually much clearer to distinguish the various contour values. Okay, so firing through, we have a new blank menu. In version 14, the blank menu has been redesigned and it uses the new primer style object menus. Okay, there are 4 different blanking modes: blank, unblank, reverse, or show only. Okay, so this uses the new object type entity selection menu, so that's consistent with everything else now. And there's a toggle switch off on that toggles if blanking is applied. Okay, now previously if you had different windows with the same model, then the blanking would be applied to all of the windows at the same time. So we have changed that now, so the blanking is not per model, but it is per window. So this itself, you can have this is model 1, and we can open a new window also with model 1 and have different items blanked. Okay, so that's quite nice. So with the blank menu, we can use the window tabs to set which windows the blank menu acts upon. So we can blank things in Windows 1 and 3 in this example, but not in Windows 2 and 4. We can also, so the other changes, again to do with blanking, but in the quick pick menu, there's another option here where instead of blanking all the windows, which is the default, and that's how it used to work in version 13, we can blank just the items in the current window. Okay. So the shortcut keys, U, which is unblank all, and R, which is reverse blanking, they apply to the window that the cursor is over. If your cursor is not over a particular window, it's just hovering somewhere else, then it's applied to all of the active windows. Okay, so I think that's a useful change. Okay, there's also another new export menu, which is activated using the shortcut key E. And we can use that to export the blanking from one window to all other active windows. Okay, so for example, in this particular case, we've blanked the body, and we have windows 1, 2, and 4 active. So if we want to export this blanking to the other windows, we can just click on E, and that will export the blanking. Okay, now window 3 wasn't active, so the blanking hasn't been exported there in this example. Okay, let's carry on. The next change is multiple on-plan integration points. Okay, so in this particular case, if you set max int, maximum number of integration points, on the database extent binary card, if it's positive, then dyna will set the maximum value to, let's in this example we've got it as 3. So you will get 3 through thickness values through the shell. Okay, so that's shown in red here. But regardless of whether you have reduced integration or a fully integrated shell element, you will only get 1 integration point averaged in the center of each through thickness integration points. On the same max int card, if we set it to a negative number, then we will get all of the in-plane integration points, and we'll also get 3 through thickness integration points. So we'll get all of this data. Okay. In previous versions of D3plot, we could plot each of the on-plan integration points individually or average them to a single point. But it was not possible to plot all of them at one time to see the variation of data over an element. So in this case, we actually have 4 data points in one element. In version 14 of D3plot, this is now possible, but we do need a ZTF file, and that has to be written from Primer. Okay, let's have an example of how this would work. So the way this works is the data point is plotted and it's controlled via a pop-up on the data menu. So this menu here on the left is the data menu. We can plot all points separately, and that is the default. So in this example, shown in the middle here with the sort of rainbow colors, the value of each point is just printed as well. So on the left-hand side, the 2 points have a value of 1.0, and on the right-hand side, the value is 2.0. Okay, so we can actually, this is one shell element, and we can plot all 4 of these integration points on the same shell. So that's very useful. The second option is to average at the center. So that's the sort of default way that we would have done things in the past. So in this case, we're averaging the values at the center, and the average is 1.5, so we get the yellow contour in the center. Yeah. Now, just going back to the top value here, this rainbow color is actually showing what D3plot would show. Yeah, so you would get this this change in color. Okay, in this case we have averaging on. Okay, so you get this gradation in color from the value 1 to the value 2 going across. Okay, and if these points were different, we would get a gradation across all 4 of them. Okay, so on the next slide we can see the difference. So I'm sorry that the scales of the contours are different, so we can't directly compare them. I'm sorry about that, but we can see the general trend and the difference that it makes. So effectively, if you have a hotspot in one of your integration points, you can now see that more clearly in D3 plot. Previously, where we had the average, that's shown on the left-hand side, we would get a lower peak value, which is in this case minus 1.7 E6. So that's shown in blue here. Yeah. Now on the right hand side we're showing you the new layer, and this is showing all of the integration points, on-plan integration points. So our peak value has gone up to minus 2.5 E6. So that's this one here in the very narrow fringe. Okay. So I suppose if we did actually have both the contours the same, then we would be able to see a much larger difference and be a bit clearer. Okay, so let's carry on. Staying on the theme of on-plan integration points, for CT and SI plotting, D3 plot transfers element on-plan values to nodes and contours using these. Okay, so there are 4 different schemes for deciding how the nodal values are calculated. All right, we have unaveraged, so no averaging of data and nodes. We have low resolution, medium resolution, and high resolution. Okay, I think the next slide explains this a little bit better visually rather than in words. So this diagram shows how each contour plotting scheme works. Okay, so for example, in this case, let's go to the low resolution first. In this case, what we're doing is we are averaging the result, and it's the linear average of all of these values. Okay, so that's done in the center. So this particular one on the left is if you have one through thickness integration point. Sorry, one on-plan integration point per element. So we've got 4 elements here. Yeah? The one on the right, again we have 4 elements, but each on-plan integration point, we've got 4 of those. So in this case, what we're doing is we're averaging just the center values. So in this case, we're averaging the 12, 7, 5, and 8 values. And we're averaging those there. Okay, so this is the low resolution scheme. So those are the ones that are averaged there. Okay, you can see the result is actually different because we're not averaging all of the data. Okay, the next scheme is the medium resolution scheme. Again, we have the same 4 elements and we have the same stress values for each of the integration points. The medium resolution takes the greatest magnitude. So in this case, on the left-hand side, it's 12. Okay. On the right-hand side, it takes the greatest magnitude out of any of these, out of the closest values. So we're choosing between 12, 7, 5, and 8 in this case. So again, in this particular case, the value is 12. That's the value you would get averaged at the center. Now on high resolution, each element is subdivided by the green lines as shown. So the more on-plan integration points you have, the more subdivisions are made. Okay, so the values are now centered at the mid-side points as well as the nodes. So we have the averaging at each of these green and red values. Okay, so that's the same on the other side. Okay, so I think describing it in words is a bit trickier than visually seeing the result. So it's worth having a go at that yourselves. Okay, and again, carrying on in the theme of multiple on-plan integration points, we can plot these using a cloud plot as well. So I think this is a very nice image, and it shows very clearly how you would display the results. And I think this image is very clear actually. So we can see what's going on here with this plate. We can also plot multiple on-plan integration points using the principal or arrows plot. Yeah, so these are the principal directions, and these are the arrows have the magnitude proportional to the stress value. Okay, so we can see each element has 4 arrows now instead of just 1. So we can see the direction of each of the integration points as well. So the principal direction. Okay, so that's very neat as well. Okay, going and carrying on with this theme again, in the right menu, we can plot each of the integration points individually, the on-plan integration points, or we can plot them all at the same time. So, and the right menu is now sort of clever enough to be able to do this, and we can put those into columns. So all of the points are output, and NA is written if the point doesn't have any valid data. Okay, so in this case, we can go to write, entity, all on plan. We can choose all points separately. We can average them at the center, or we can choose individual integration points. Okay, and now remember, this is just for one through thickness surface. Okay, so let's choose the middle surface through the thickness, and then we're going to choose all integration points on plan. Okay, so then we get 4 columns of data, so value 1, 2, 3, and 4. Okay, so OP is on plan. The right menu, we've got some enhancements, I'll talk about them later, but we also have the total value and the average value as well in the right menu. So all of these can be written as text, CSV, or Excel files. Okay, in the XY data menu, which is very similar to the right menu, but it gives you a graphical view as well, we can also plot all of those points individually or averaged, or all of them together. Okay, and we'll get 4 values per element. Okay, so the next item is the right menu. In version 14, the right entity menu used the same primer style object menu. So again, we're being consistent. We're reverting from the sort of the previous individual panels to the primer style menus. Okay, so we can go to right, entity, and then we get the primer style menu. Okay, if entities are selected from multiple windows, then the model number is displayed along with an extra column showing the time, because your different models might have different output timings. Okay, we can sort by ID, entity ID, or by model ID. We can also sort by time or by value as well. If right scan is used with the envelope option, to scan values across multiple states, then the right table now displays the time for the minimum and maximum values. Okay, so that's useful. Okay, so I'll give you a demonstration on the right menu later on. Okay, the next major enhancement is in volume 3. So D3plot supports the stochastic particle domains that are used to model explosives. So those are the two keywords there. The new domains also supported are the new mechanical domains, which are defined at the boundary between a CESC fluid and the structure. These mechanical domains can then be used to view the forces and heat transfer variables across the boundary. So we can now plot those. Okay, in version 13, volume 3 elements could only be removed by either blanking the whole part or by using a cut section. Okay, in version 14, volume 3 elements can be blanked individually, and they can be blanked using the quick pick or via the blank menu. Okay, so I know this doesn't show the mesh, but I will show this as an example. So this red block is a volume 3 block, and it's consisting of, it's been split into a number of different elements. Okay, so we can blank the individual elements now. Okay, we can also use volume clipping. So we can have the clip switch, and in this case we've clipped a volume so that we can see just this particular area now. We can also use a limiting switch, which will exclude data using limiting values. So in this case, all the data in red and pink has been omitted because we've set the upper bound value at 43, which is just in that contour there, in the yellow contour. So all of that data is omitted. Okay. The next item is streamlines. Streamlines follow a velocity vector field. They are different at different states. Okay, so there's two examples given here where we have the streamlines at 113 seconds and 126 seconds. Okay, streamlines are available for visualizing the flow in ICFD volumes. Okay, so it says in D3plot, streamlines are computed using the fourth order Runge-Kutta method with an adaptive step size. So for those of you doing ICFD, that's just a little background of how the streamlines are calculated. And the streamlines tool is in the utilities menu. Okay, so it's in the top right hand corner under tools and then utilities. In order to generate a streamline, we can either have a collection, a group of streamlines with some start points, or we can select some nodes in the existing ICFD analysis. Okay, so these are two examples of how we can select some streamlines. We can edit the group, or we can start it from a point or line source. Okay, so just to finish off that point, the center or point 1 and 2 can be input coordinates, the center of an element, or the coordinates of a node. Okay, so each of the groups has a color which are used in the shaded plots. Okay, and we can have a group of starting points per window. So in common with the theme, we can now do things per window in D3plot. Okay, per window settings are in the lower part of the Streamlines menu. Streamlines can be calculated using different vector fields. So for example, the ICV field is here and the ICV average velocity is here, so the streamlines are slightly different for the two. Streamlines can also be shown in just the forwards or the backwards direction, and multiple components can be used very effectively when in combination with streamlines. So what we can do is we can plot streamlines on top of different components that we can plot, different contour values. So we can plot up to 2 scalar components and a vector component simultaneously. Okay, so we'll have a quick example of that later on. So again, this is just showing you the different types of plots that we can achieve. So we can have fluid pressure with the volume, or fluid pressure with streamlines. Okay, we can also have 2 different scalars and the streamlines plotted. And we can also have the vector. So a vector would be, let's say, a velocity plot. So this particular image has a lot of information on it. It's quite graphically effective. You can see what's going on here. Okay, we have some new data components that are supported by D3Plot14. One of those is the plastic strain tensor that is available for solids and shells. Another one is the thermal strain tensor, again available for solids and shells. So we get that in the usual menu, so we can go into category and then select a component. D3Plot also supports multiple different interface files. So for example, the CTF file is a contact force file. That's been supported for a long time. Okay, some of the other files, blast, fluid structure interaction, CPM and DEM force files. Okay, so the format of these files is different, and each file contains different data components which are available under the contact and interface data categories. So that's for these 2 files. And in version 14, these component categories have been modified to make it clearer on which components are available from which file, and some new components have been added. So that's probably better explained in this slide. In version 13, all of the components were available, so the user was required to know which ones are applicable. In version 14, the menu is divided by file type, and only the valid components are available. Okay. Okay, so another change in version 14. The contact component category contains 7 new segment-based contact force components. These components are similar to the nodal components and are calculated by dividing the nodal forces by the number of contact segments at each node and then summing these up. Okay, so this is a new menu, some new results that are available, and a comparison of the nodal versus segment data component plot is here for a particular example. Again, I'm sorry, the contour values don't match up, but we can see there is a difference. Let's say this is a hotspot there in the nodal, but when we average those over the segments, we don't have that. Okay, PTF Cuts is a tool that we can use to cut down the PTF file size. So this slide is probably a bit old. It says the average full car model is 5 million elements. It's probably 15 million elements, I guess. The largest current model is 25 million elements. I don't know if that's true either anymore. And the future large model, 100 plus million elements. Okay, I can certainly believe that. Let's take the largest model, 25 million elements. Each plot state is about 4 gigabytes. So that's, I mean, there's a lot of data to transfer for each of these analyses. Yeah, it takes a long time to do that. Without going into this slide full of further numbers, what we can do is we can use PTF Cuts to reduce the size of your PTF files. We can either reduce the number of states, or we can reduce the number of data components. Okay, so, and the output can either be in the standard LSTC format, or we can use a D3 plot native format. Okay, the reordered format can also be used to pre-calculate and embed some additional data components. Okay, so just give you an example. So I think I had an example somewhere. Okay, it's coming up in a later slide. We can also use PTF Cuts in batch mode. Okay, so you can set it off to output these particular components, for example. We can use it in batch mode to output just the even odd states or a start-finish state. And we can use the reordered format, which is the native D3 plot format. Okay, there are two methods of generating the cut-down models. We can use a command file option, or we can use an options file. Okay, if you use the options file, this has an advantage that we can generate multiple cut-down models, each with its own components, formats, and states. Okay, so for example, if we use the options file here, in this case we have all the states and displacements only. Okay, so that's what we'll get. Okay, and these are the data savings that we can expect. So for our 4 gigabyte initial state, if we just want the displacements only, we've cut down the model from 215 gigabytes to 15 gigabytes. So that's a huge saving there. And if we want some stress results, then they've estimated, let's say, 15 gigabytes for displacements and 1 meter stress. Okay, so those are obviously estimates, but it gives you an idea of the power of this, especially for very large models. Okay, so those are the updates for D3 plot. So I'm going to move on to THIS now and give you the updates for THIS version 14. So reading files, there's an update. We can read some new data files. So we can read files relating to particle blast, pressure tube, and a bearings element. Okay, so those are the components. We can also read in files for the multi-physics databases, so CESC cards and ICFD cards. So that's very good. The next update is in scripting. So THIS version 14 has a new JavaScript functionality for opening models and extracting data. So data component constants have been added, which are like those in D3 plot. So these are the different functions that THIS can now use when you define your JavaScript. And THIS has some JavaScript functions to flag items in a model, and also to find items in a model. Okay, and I won't go through that example there, but it's something to note that we can THIS JavaScripting is now much more powerful. For entities like shells, thick shells, and solids, the getDataFlagged function has optional arguments to specify the integration point. So that becomes much more useful, I think. And in terms of JavaScript functions, we also have functions for curves. So these are specific to THIS because they are performed upon the curves. Okay. And just finally on the JavaScript, the entity class now includes subtypes, component constants, constant codes for data components are similar to those in D3plot, and we have an XML parser class. So one of the problems or one of the barriers to writing JavaScript is that it can be time-consuming when trying to remember which functions are available. In Primer 14, in THIS 14, as with Primer 14, we have a file that contains the information required to configure IntelliSense with Visual Studio. So that Visual Studio knows this about the THIS API functions. Okay, so if you need help setting that up, please do email our support and we can help you do that. Okay, so the next, I'm running out of time, I think, but the next slide is this section is about 5 minutes, and then we're talking about Reporter 14. So the following new templates will be issued. There are the US NCAP templates, the side impacts, and we also have general dyna and general vehicle model. Okay, so these are the templates for the US NCAP. So that's the side impacts and the side pole. And this particular one here is a general dyna model template, and you'll notice that we have some standard checks here. For example, added mass, termination status. Okay, so, and we've plotted the energy time history, and then we've got some standard views. I think this is probably just before the start of the analysis on initialization, and this is probably at the end of the analysis. So we've got some standard results there as well. Now, an improvement in Reporter 14 is adding and deleting rows in a table. So we can now do that in any position in the table. And to do that, you just right-click on a cell, and you'll get some options. Okay. We can also merge cells in a table, and we can edit borders and perform extra features on tables themselves. So that functionality is improved. Okay, we can also have conditional formatting. And the final thing to say is it's much easier to get data back from D3plot or THIS as a variable to use in Reporter. Okay, so for example, the maximum value or time of maximum value for a curve in THIS, or the maximum displacement or stress for a state in D3plot. We can bring those back now and use them as a variable in Reporter. Okay, so that's the end of the presentation. What I will do now is I'll go through two examples. They're both in D3plot. So let me open those up. The first example is for multiple components, and we'll combine that with a demonstration of the CESC values. So I've just loaded that up. Hopefully everyone can see D3 plot there. So this is actually the example from the presentation earlier. Okay, this model is a volume of air moving around some structural elements. I will animate the model. I don't think it will work particularly well over the webinar, but I hope you can see that. I've just stopped it now at plot state 4. What I'm going to do now is just go to, so I've taken a cut section through the volume. Yeah. Okay. So now I'll just show you the data component, which is CESC component, and I'll plot the pressure. Okay. So as we can see, this is exactly the same as previous versions of D3 plot. If you only want to plot a single component, you don't have to do anything different. So in this case, I've gone to scalar 1 and I've plotted this one component. Yep. The component you can see is only being applied to the entities for which it is valid. So in this case, the pressure is valid for the volume of air. Okay. The other structural elements remain grayed out. Okay, so hopefully everyone can see that. What I can do on top of this is plot another component. In this case, I'm going to activate scalar 2 and I'll plot the X direct stress. So I'll press CT again. Right. Now you'll see that on the screen, the volume of air, the component there, the pressure hasn't changed. The contours remain the same. But for the structural components, we can plot the X direct stress. Okay, so that's now showing up. And in the contour bar, we have two columns there. So the CEV pressure is on the left-hand side, so going down. And then on the right-hand side, we have the global X direct stress. Okay, one thing I will say is each of those can be individually changed. So these are the automatic default values. Occasionally you might want to tweak those. You can do those individually for each of the scalar 1 and scalar 2. Okay, so I can change this just for scalar 2 and it won't make the change to scalar 1. So I've got a lot more manual control over the way my plot looks. Okay, I'll now just turn off scalar 2. So we'll go back to just showing the pressure. And I'll just go to the vector tab. And what I want to do is I want to show the velocity, which is the CEV fluid velocity. And I'll turn on the vector tab. If I press CT, now I've got two components. One of them is a scalar and one of them is the vector. So you can see the vector comes up with an arrows plot, which is colored as per the contour levels. Okay, so I don't know how well people can see that, but if I zoom in just a little bit, hopefully you can see that a bit more clearly on your screens there. Okay, now I'll turn scalar 2 back on. So I'll just zoom out. Let me do part screen so you can see that properly. So I'll zoom out. So I've turned scalar 2 back on, and now what you see is the vector arrows automatically turn gray. Okay, so we're back to plotting the pressure on the volume of air, the X direct stress on the structural components, and the vector is shown in gray. Okay, so the vector components, which is the CEV fluid velocity. Okay, so that's the first example. I've got another example as well. So in this next example, this is a Beeman Shell model. Okay, so and this represents a floor slab with columns extending top and bottom. Okay, so this example we can show options for controlling what is plotted and how. Okay, so what I'll do now is I'll go to display options. The beams are currently shown as thin lines. If I go to beam symbols and then change it to true section, I can actually show the true section of all of these beams. Okay, so if I zoom in there, I can see the true section. Okay, so in order to do that, we need the ZTF file. So the true sections are not written in the PTF files, but we can extract that from the primer. And primer will also write the offsets of the beams in the ZTF file. Okay, so I'll show scalar 1. I'll set that to displacement Z. And then the scalar 2 will set to displacement Y. Okay, so I'll just zoom out again. Now, if I plot this, what I end up with is the components are plotted by entity type. And if both components are valid, which in this case they are, then the second component is used. And we can see the first component, which was DZ, is not given a value. So all of these values for the beams and for the shells, they're plotting dy. Okay. So now I'll change scalar 2 to beam axial force. Okay, in this case, scalar 2, axial force for beams, is not valid for shells. So shells will show scalar 1, which was dz, and the beams will show axial force. Okay, so the default is scalar 2, yeah, effectively, unless scalar 2 cannot be plotted, in which case you go to scalar 1. Okay, I hope that makes sense. I think it's more intuitive if you come to do it yourself, actually. Okay, now under scalar 2, we can change the options. So we can go to scalar 2 options, and instead of plotting CT, which is continuous tone, for all of the elements, we can actually change that to anything that's relevant for these components. So in this case, scalar 2 is just for beams, so we only have beams, so we can plot dp. Okay, so if I just refresh that, in this case what we're getting is the axial force plotted using the dp method. Okay, so I'll just turn off scalar 2 again. So now that I've turned off scalar 2, everything is plotting dz. Okay, and now that I'm in scalar 1, I can go to scalar 1 options, and I can turn off plotting on the beams. Okay, so I can just turn that off. Now, in which case, the beams are now grayed. So nothing is computed for the beams, only the shells. So you can see I've got much more control over what is plotted, how it is plotted, and I can even plot multiple components on the same display. Okay, so I'll just toggle the value. So that's plotting DZ for the beams and the shells. And if I turn that off, it's plotting it just for the shells. So I've got a much more control there. So that's nice. Okay, so just to summarize, if you want to plot a single component, like DZ, there is no difference compared to previous versions. However, the additions mean that you have much more control and flexibility about what components are plotted and how these are displayed. Okay, so that's the end of that particular example. I've got one further final example, and this one is to do with the right menu. Okay, so this is just a component of a vehicle. It's a part of the crush component, so at the front of the vehicle. Let's go to the right menu. So I've just gone to the end. That's the right menu. We can click on Entity, and then you'll notice this menu is now the version 14 style. We can click on Shell, and then I'll select all of the shells. Okay. Component, if I right click and I want the von Mises stress, so I can do that. And I've selected middle surface there. If I click on apply, this is the new right menu. Okay, so some of you might be familiar with this already. So in this case, I can always see the totals and the averages. And I can scroll to any entity on this list. Okay, if I right click on that and click on only, that will highlight just that entity. Okay, so I can just click on all to unblank everything and go back to that. Okay, so let's order it by decreasing value, and I can just click on the von Mises stress. Now I want the highest value there, so I can click on only auto scale, so that's selected that for me. Now it's not entirely clear where this particular value is, so if I go to attached, attached has been there since D3 plot version 10. I can just find the attached part and click on apply, and that will unblank the attached part. Okay, so that's quite handy. I'll just do a line plot. So this is the part that we have. If I right click, I can also sketch where that element is in the part. So hopefully people can see that it's grayed. Okay. So now I'll just demonstrate, I'll go back to the right menu and I'll click on all shells again. Right. I can expand this menu now, and I can get multiple components for multiple integration points. So for the second component, I will select X direct stress, and then for the third component, I will do X direct stress for the top integration point, and the fourth component I will do resultant displacement. Okay, so I'll click on apply, and I'll get a table of values here. Okay, so all four of these components are shown at the same time. We can write this data directly to a text file, to a CSV, or to an Excel file. Okay, so that's that. If I open a text editor, so I've just got TextPad open here, I can select a bunch of this data, and if I right click, copy to clipboard as text plus extra, and if I paste that, I will get that in text format. Okay, the extra means it will give me the headings and the totals as well. Okay, I can also go back and copy it as just a CSV. So if I go back to the text editor, that's copied it as a CSV. Okay, so I think that's useful. Okay, I think I'll just bring the contact details back up online on the screen. That's the end of the presentation and the end of the demonstrations. Thank you all for your attention. There aren't any questions. If anyone has any questions, I'll stay on the line for a few minutes afterwards. You can type it in. Otherwise, thank you very much for your attention. And that's the end of the webinar.